Okay, just did the video explaining the process of doing an indefinite integral. So let's go ahead and do a couple examples. So remember, we're asking what was the original function whose derivative is 16x cubed plus 3x squared? And remember, there's always a possibility that the original had a constant. So what we're going to do is remember, this piece right here is the command. So we're undoing it. So we put uppercase f of x, and I'm going to go ahead and write 16x cubed plus 3x squared plus the possibility of there could be a number right here. So I'll put plus 0, and then when we take the derivative of that, we don't know what number it could possibly be, so we'll put the constant c. All right, so we're going to add 1 to the exponent. 3 plus 1 is 4. Divide by 4. Add 1. 2 plus 1 is 3. 16 divide 4, so we've got 4x to the fourth plus 3 divide 3 is 1. 2 plus 1, x cubed, plus uppercase C. So that's that one. Let's go ahead and do this. Now you have to be really careful with some of these, and I'll come up with an example. If you've ever got a -1 here, there's a different process that we're going to do other than this. So we're going to add 1. -4 plus 1 is -3. And then we'll put plus 0. So that becomes x to the -3rd plus c. And so what I'm going to write this as is 1 over x cubed plus the uppercase C. All right. So now we have a fractional. So the process is still the same. So we're going to add 1. When I add 1, I'm going to add it as 3/3 because that's the same as 1. So that's 7/3. So rather than doing this, well, we could go ahead and do that, but then you're going to multiply by the reciprocal, and then we'll put plus 0. Now, so we are multiplying top and bottom by this reciprocal. Those cancels. 35 divided 7 is 5. So you have 5x, and then 4/3 plus 7/3, or plus 3/3 is 7/3. And then how you check it is, how you check to see if you did it right, take the derivative of this. So we're going to multiply 7/3 times 5x, and then 7/3 subtract 1, because now we're doing the derivative. So that becomes 35/3 x. 7 subtract 3 to the 4/3. Is that what the original was? Ta-da! And then the derivative of a constant is 0. So we're back to what this original would have been. So that's how you can check to see if you did it right if you don't have an answer key. Okay, so when you've got something that looks like this, the first thing you're going to do is rewrite. So we're going to write that as -2x to the -2, and it really should look more like that. All right, now, so -2x to the -2nd plus 0. So I'm going to add 1. That makes it -1. -2 divided -1 is 2. negative 2 plus 1, this right here, is negative 1. And then I'm going to rewrite that. So this says 2 over x, just like that. All right. The tip here is to rewrite this as a fractional exponent. Now, also, by the way, some professors might say this constant, we can actually, I'll show that in a minute. I'm going to rewrite this as x to the 1/3. Okay, so this is probably how I'm going to do it. But what some would tell you to do is bring out that 8/3 in front of, and just make that a scalar, right? Or the reverse distributive, and that just becomes a multiplier. So there would be two different ways to do that. And I could go ahead and show you both. So I'll do it this way first. So we're going to add 1. Whoops, 1 is 3 over 3. So that's 4/3. So remember, division is the same as multiplying by the reciprocal. So instead of dividing by 4/3, we can go ahead and multiply by the reciprocal. That kind of saves a step. And then put plus 0. So those cancel. 8 divided 4. So that's 2x to the 4/3 plus uppercase C. So over here, what they would tell you to do is they would tell you to, this would be the, and sometimes this is easier. So x to the 1/3 plus 3/3. So we're going to divide by 4/3. So it doesn't, I guess, really change a whole lot, but sometimes it's easier with this multiplier being on the outside. All right. This is the one that I'm talking about. When you have a negative 1, okay, when you have negative 1 as the exponent, the first thing you're going to do is rewrite this negative sign. I'm going to bring a negative 1 out front, and then I'm going to write that function like this. Now, well, whose derivative is 1 over x? Well, the derivative of ln of x is 1 over x times the ln of e, which cancels. So to work backwards, when you've got 1 over x and the number pulled out front, so you're going to say this. Negative 1 out front, and then the derivative, you're going to say ln. Now, you're going to do absolute value bars, because remember, you can't take the log of a negative number. So you put ln of x like that, and then plus c. Now, if you wanted, you could just put, you don't have to have those parentheses right there. That was unnecessary. All right, so that one, yeah. So notice these two are the exact same thing. We just rewrote it. This one is when it's not in the form that we want. This is the form that we do want. Okay, e to the x. Remember, if you have the function e to the x, well, the derivative of e to the x is e to the x times the natural log of e times the derivative of x, which is 1. That cancels. So that leaves e to the x. So when you integrate e to the x, you go back to the original. So we could bring a 3 out in front, and then e to the x dx. So 3 just becomes a multiplier, and the integral of e to the x is e to the x plus the uppercase c. Okay, real quick before I leave this one right here, so remember when you're finding the derivative of e to the x, you multiply by ln of e. Well, when you work backwards, you would divide by ln of the base is e, but ln of e is 1, so that cancels. So typically we don't have to write that, but that leads us into the next one, and then I'll stop after this one, and I'll do some of the new ones in the next video. So I'm going to rewrite this with the multiplier on the outside. So we're integrating 3 to the x. So we're going to do the multiplier. And then to integrate 3 to the x, well, remember, when you have an exponential, it's the original times the natural log of e. So instead of multiplying, we divide, natural log of the base, and then the integral of 0 is just a constant. All right, I think that's it for this one. Yeah. Yep. The next one we'll talk about some of the trig functions, doing the integrals of those, and then we're going to talk about the chain rule in the next video. All right, that's it.